All right, problem number 7, we have 3 parts. It says for a parallel structure of identical components, the system can succeed if at least one of the components succeeds. Assume that the components fail independently of each other and that the component has a 0.17 probability of failure. So we're going to complete parts A through C. And then part A says, would it be unusual to observe one component fail, 2 components fail? Okay, so probability that one component fails, I'm going to say P fail, that is equal to 0.17. And then if we have the probability of 2 fail, given that we know they are independent, so fail and fail, that would be 0.17 times itself, or 0.17 squared. And I think that gives us 0.0289, but let's double check. 0.17 squared. Yeah, 0.0289. All right, so in the textbook, it talks about unusual events. An event is unusual if it is less than 0.05 or 5%. Okay, so 1 failing is not going to be unusually low, but 2 failing, 0.02 is less than 0.05. So the fact that 2 would fail would be unusually low to answer those questions. So it would not be unusual to have 1 fail, since that probability is 0.17, that's what was given, and that is greater than the 0.05. It would be unusual to have 2 components fail, since the probability that 2 fail is the 0.0289, which is less than the 5%. So it's a really small chance. All right, part 2. What is the probability that a parallel structure with 2 components will succeed? Okay, so the probability that it will succeed, so I'm just going to say probability that it would succeed, okay, is going to be equal to 1 minus they both fail. So this is the same thing that we computed in the previous problem. So if you take out the chance that they both fail, then that means that's going to be what you get if one of them succeeds. So probability of, I'm going to say F and F, fail and fail. That is equivalent to 1 minus 0.0289, and that will give us 0.9711 when we subtract that. So 0.9711 is the probability that at least 1 would work, and that's all it takes for the parallel structure to succeed. As it's set up here, the system can succeed if at least 1. So this is that at least probability. So when it says what is the probability that the parallel structure will succeed, that means at least 1. So this is that at least probability, and that will give us 0.9711. All right, and then part C wants to know how many components would be needed in the structure so that the probability the system will succeed is greater than 0.9998. So what we're given is we want the system to succeed, so this setup here, but we don't know how many we need, so we got to figure that out. So usually I'm raising the number of failures to some power. So on part C, we're looking for the probability for this thing to succeed, which they're giving me. We want that to be 0.9998. We want to be greater than that, 0.9998. That's going to be equal to 1 minus some number of failures. So the probability that, I don't know how many failures we need, so we'll just say to the x power. this probability of failure is 1 minus 0.17 to some power. So one thing you can do, you can just kind of guess and check and plug in. Now I know when we did 2 systems we got 0.97, so it needs to be more than 2. There's 2 ways you can do it. You can guess and check, so you can just kind of plug in, 3, 4, 5, 6 and find out what number would give you this. Or you can solve it algebraically. You need to know some college algebra and logs. So the way that will work is I would subtract 1 if I'm doing this algebraically from both sides, and I'll show you both methods. That 1 will cancel. Subtracting 1 would give me a negative 0.0002, and that's going to be equal to a negative 0.17 raised to the x power. All right, we need to get out negative times a negative is a positive, so we can basically divide both of these by -1, and that will get rid of the negative. So I have 0.0002 equals 0.17 raised to the x power. Now I need to get this exponent out of the power position, so you can take the log of both sides. So if I say log of this side, I would also do the log of this, and when I do so, property of log allows you to bring that down. So this is an algebra concept. Log 0.0002 is equal to, bring that x down, log of 0.17. And now I can divide by log of 0.17. So that will divide out, and this would give me what x is. So I'm going to show you that, and then I'll just show you the guess and check. Guess and check will probably be the easiest for you guys to do. But if I do, and the calculator has this log button, log of 0.123 zeros and a 2, we're going to divide this by log of 0.17, and that gives us 4. So we need to round up because 4 wouldn't be enough, so we'll say 5. So if I do this in the calculator, guess and check, I'm just going to do a equation. So I'm going to say y equal is 1 minus 0.17 raised to the x power. So the calculator is going to put 1, 2, 3, is going to plug in all those for me. I'm going to look at the table. So I'm going to go second graph to see the table, and I'm looking at these y values. So if you scroll over to the y values, you got 0, 1, 2. That's the one we had. Well, we had 2 failures, which is a little bit higher. We can't see it right now. So we had 2 failures, system with 2. That's that 0.9711. With 3 is 0.995, and we need 9998. With 4, we have 9991, and we need greater than 9998. But when we get to 5, we got 0.99986. So this will be greater than this one. So that's what we got from the calculator. Whenever we did that log, we got 4.8, but you want to round up because we want to go a whole number. So 5 is the number of components we would need to have that probability.